Okay, so what we're working on today, we are working on simplifying rational expressions by multiplying and dividing. So we need to get going for today. Topics that we're going to be talking about for today. So, simplifying rational expressions, we're multiplying and dividing today. Tomorrow we're going to be doing adding and subtracting, and then we're going to review and then eventually get into graphing. So this is all about rational expressions. You should have done some of this in Algebra 1. So, but again, it's been a while since some of you guys have done this stuff. So we're going to have to remember some exponent rules and some factoring and some other good stuff that we've done from the past. So in this first problem, do you remember how to cube this? Way back from polynomials, that was the last chapter we did in first semester, actually. So the -2, what happens to that? It gets cubed. So remember, it's not -2 times 3, that's -2 times -2 times -2. So that will give me -8. And then we're going to remember with the exponents, what do we do with the exponents? We multiply. So we're going to do 2 times 3. Normally we add them, but if the exponent's outside the parenthesis, that's why we're timesing. So we're going to have 6x's and 3y's. And the denominator is fine. Okay, then after that, we're going to do some canceling, and you might remember doing this from our polynomial chapter. So we can cancel anything in the numerator and the denominator as long as they have something in common. So we can take away how many x's? 5. So we can take away 5. We can take away how many y's? 1. So there'll be 2 left in the numerator. And then also -8 and 4 have something in common. Don't divide those. Well, I mean, you can divide those, just don't like take away, like subtract. So like here, 4 goes into these, so 4 goes into 4 once. 4 goes into -8, -2 times. So in my numerator, I'm going to have a -2xy squared over 1, which technically we can just call that -2xy squared. And that's my answer.
Like what we're doing in this is like simplifying stuff?
Yes.
That eventually graph.
So we're not going to be doing, there's no more trig anymore. So there's no more sine, cosine, tangent, all that stuff is gone. Yes. Okay. All right, number 2. A big mistake that students make for this one is they want to cancel the m's and cancel the 5 and the 10. Now, I could cancel here because all of this is put together with what operation? Right, multiplication. When it's addition and subtraction, I can't do anything unless I make things look identical. And to make things look identical, usually we have to do something called factoring. So the numerator's fine. There's nothing really I can do with it. But the denominator, I notice that there's something in common. There's a GCF in there. I can take out a 2. And I want to do that because if I do that, 2m divided by 2 will just be m, and 10 divided by 2, which will be 5. And the reason we want to do that is I can only cancel addition and subtraction if they have directly matching exact terms. So like I can cancel now the m plus 5 and the m plus 5 because they're identical. So since they're identical, I can cancel that. There'll be a 1 here, and cancel that. There's still going to be the 2 there. So my final answer is 1/2. But again, with addition and subtraction, you have to factor. You can't just cancel like we did in number 1. Okay, number 3 is a lot like number 2. So the numerator is fine, but again, the big mistake students do is they want to cancel x's right away. We can't because of this subtraction sign. So what we're going to do is hopefully notice that they have something in common in the denominator, x. So we're going to take that out. So if we have x squared, we're going to take away one of the x's. We're going to have x left minus x, take away x. That's going to be 1. Okay. Can't be 0 because if it was 0, then that term wouldn't exist because 0 times anything is 0. Now, because this x is being multiplied, this single x can now cancel with that one. So then I can cancel this and this, and then all that's left is 4 in the numerator and x minus 1 in the denominator. And that's my answer. Okay, so those are just single one fraction. So what we're going to take a look at with two fractions is, can I multiply them and divide them? So just as a quick rule, I'm a person that loves to cross cancel, which means I can cancel anything I want as long as it makes a bow tie. So the reason I know that is because numerator, denominator, that makes these two sides. But I could do a numerator here and a denominator here, or vice versa, and so that's why we say a bow tie, because you can't cancel across or like across on the bottom either. So like for example, do you see something in common that we could cancel? Yes. So 9 goes into 63 7 times. Okay, what else could we cancel? We can do that too. We can cancel a b, and then there'd be 2 b's left on top. Okay, what else could we cancel? Yep, the 7 and the 35. So 7 goes into 35 5 times, and then an a. So there'll be 1a left on the bottom. And then multiply across. So 1 times 7b squared is 7b squared. And 1 times 5a is 5a. Double check and make sure if anything else they have in common, but they don't. So that's my answer. Now, some students might not like to cancel. Canceling to them like this is very, very confusing. So here's another way, because some people don't like cross canceling. I do, because I don't like working with big numbers. I like to be able to do things without using calculator. So one thing you could do is you could multiply across. So I could do 7 times 63, and so that would give me 441. And then write my letters. I have an A and 3 B's. And then do 35 times 9, which is going to give me 315. And I'm going to get 2 A's and a B. See, this is the reason I don't like this method, me personally, because I have to figure out what goes into both of these two. So actually 63 does. So that's where the 7 comes from and the 5 comes from. And then I can cancel an A and then cancel again a B. And I'll get the same answer.
Well, you're going to have to do it that way for next round.
No, there's division is different, right? What's the relationship between division and multiplication? Yeah, we're just going to flip the second fraction. So in the next example, number 5, that's all we're going to do. So you have to remember that the first fraction stays as is. But yes, Mikhail, I could do that one that way, like the way I did before with multiplying across and then canceling. It's just not my particular preference because I don't, again, like to work with big numbers. So I can do the problem both ways, though.
This one gives you the cross.
You flip the second fraction, and then you can cross cancel again and do the same process.
So like the last one, you just divide or multiply 7 times 63 and stuff like that. Can you divide 4 by 2?
You could, because in a way you are kind of doing that, yes. So I can take away a 2 here, and then that would be 2 here, which is really 4 divided by 2. And then I can take away 5 out of here. So 15 becomes 3, because 15 divided by 5 is 3. I can cancel an x. So I have 1x left. I can cancel 1y. So I'm going to have a y left in the denominator. I'm going to cancel 1a. So I'm going to have 2 a's left. And the b's directly drop. So all that I have left in the numerator is 2x times 1, which is 2x. And then 3a squared times y, which would just be 3a squared y. And then that's my answer. If you wanted to just leave the original problem without the cross canceling, you could. You'd have 20 ab cubed x squared y, and then multiply the bottom across, and you'll get 30, and then a cubed b cubed xy squared, and then start canceling. So again, you can see where the 2/3 comes from. I can take away 10, and again, cancel an a, so there'll be 2 left. The b's are gone. Take away, there'll be 1x left on top, and then 1y left on the bottom, and you'll get the same answer. So if you like multiplying across, go ahead and do that, and then reduce. I just don't like to do it that way. So there's 2 different ways to do that. Okay, but 5 is totally different than 6. Okay, what is the difference between that problem and that problem, other than its multiplication? Notice the signs. Were there any plus signs or minus signs in number 5? No. So when there's plus signs and minus signs, the first thing you need to start thinking in your head, oh, I got to factor. Okay? Because that's what we're going to have to do. So the top one's already factored. That one's nice. And really all that means, again, is I'm going to have 2 of these. So, do you think you remember how to factor that? So what 2 numbers? Yes, why would it be the same as the top? What 2 numbers multiply to 9 and add to -6, which will be -3 and -3. And so those will, yes, these will automatically, I'll cancel them out in a moment. Okay, the top, what do they have in common? I could take out an m. So then I'm going to have m squared minus 9. Okay, somebody tell me something smart with that now. Yes, so we're going to have a whole lot of canceling going on. So technically I could have factored this more, but I don't need to because I have a direct match. Okay, so anyways, so the m3 minus 3's are directly the same and they match. And then the m squared minus 9 cancels with that m squared minus 9, and you guys are right. All that's left is m over 1, which is just m. All that canceled out.
If you like simplify it even more instead of flipping 2 and
So you can't do anything until you factor. You have to factor first, and that's what students have mistakes with. They want to just be able to directly cancel stuff, and we can't. Okay, the last 2. So this one, again, both of these are division, so don't forget to do what to the second fraction. You're going to flip it. Okay, where do you see something that looks like it needs to be factored? The left side's actually fine. There's nothing really there, nothing squared, so that one we're okay. It's the right side that's nasty. So, how do I factor this? Anybody remember how to factor the difference of 2 squares? Because you're thinking, in essence, what 2 numbers multiply to 9 and add to 0, because there's no middle term. Or you could do it this way. I always think of put an x there, put an x there. What's the square root of 9? 3 and 3. One's plus, one's minus. So that's how I remember. And then the bottom, you're playing the number game. So what 2 numbers multiply to -12 and add to 1? Because there's a 1 hiding there. So we're going to have, remember, it's multiplying to -12. So one's plus, one's minus. So it's going to have to be plus 4 and then minus 3. And so now that's factored. So once you factor it, that basically, in essence, is already kind of gone. So we have to do the factoring piece. And then again, we got to look for the direct parts where we can cancel. So anything look like we can cancel it? And we make a bow tie? Yep, so this x minus 3 can go. There's one more. X plus 3's can go. So in the numerator, all that's going to be left is an x plus 2. And the only thing in the denominator is going to be an x plus 4. Now, some people will still try to cancel on me and say, well, I can cancel the x's and I can cancel the 2 4's. No, you got plus signs. You can't do that. That's illegal. So that's my answer. I cannot go any further. Okay. Last one. Again, we have to flip that second fraction because it's division. So only do that when we're dividing. And then we have to figure out where we need to factor. So let's look at, what about y plus 2? Is that okay? Yeah. What about this bottom one? Does it look like it needs to be factored? Yeah, call the GCF, pull a y out of it, I agree. So we're going to have y plus 5. So I'll give a that. Okay, what about this one up on the top? Does it look like you can factor it? So we're going to do what numbers multiply to -25 and add to 0. So plus 5 minus 5. So you guys that don't like to factor, we need that so much. And then this one's already factored because there's parentheses, so we're going to leave that alone. So anything that matches that we can get rid of. There's something that matches. the y plus 5s. Ugh, I think that's it. So we can't do anything else. So in the numerator, this one's going to be kind of a big answer, but if there's two things left, then just put them each in separate parentheses. You do not need to FOIL it out. Just leave it alone. And then in the denominator, be careful. We've got a y here and a y here. So that's going to be y squared. And then I still have that y minus 2. And so that's what my answer would look like. It's horrible? Well, that's because not a lot of things canceled, so that's why it looks nasty. What would be more fun is if we had to graph it. That'd be nasty. Questions about multiplying and dividing. So tomorrow we'll do adding and subtracting, and then we'll review the two concepts all the way together.